Yes, very good morning to all of you. Am I audible?
Good
Good morning,
morning,
sir.
sir.
Good morning, sir.
Yes, sir.
Okay. So welcome back to the session of engineering mechanics. So now today we will move on to the next chapter, that is unit number 2. So we have studied unit number 1. Is there any doubt to anybody in the unit number 1? Have you solved? I had given one problem homework. Have you solved?
Yes, sir.
I got some response through Telegram and WhatsApp also. Okay, some students have solved and they are sending me through the WhatsApp or Telegram. Okay, I was checking. They are getting correct answers and all. So like this, all of you have to be participate. All of you have to be active. Okay, whatever question is given to you for the homework, you have to at least try. Whether the answer is correct or not, that is immaterial. So first you have to try. Okay. So all of you have to solve all the questions, whatever I have given. So till now I have taken around 22 lectures. Okay. So is there any doubt to anybody? किसको doubt है क्या? From the first, because when you are going for the next chapter, okay, that is equilibrium of the forces. So your first chapter should be strong. You should be in a position to calculate the that is what sigma fx, sigma fy, resultant force, okay, and moment. आपको ये समझ में है तो नेक्स्ट चैप्टर आपको इजीली समझते, नहीं तो you will not get. All of you are clear with the first chapters?
Yes, sir.
Okay, so what
Yes, sir.
we have studied there, that is purely concurrent force system, coplanar concurrent force system or coplanar non-concurrent force system. We have studied only these two. Coplanar concurrent, एक ही point में act होता था concurrent, नहीं तो coplanar non-concurrent force system. Okay, so here what is our aim? You have to find out resultant force, magnitude of the resultant force, direction of the resultant force, and sigma fx and sigma fy. Correct?
Yes, sir.
And also the position of the resultant, that is intercept, x-intercept, y-intercept. We have found out. We have solved varieties of problems. Okay, those are the important problems for your theory university exams. Okay, if it is multiple choice questions, if your exam is multiple choice questions, and whatever the assignments that is given, I mean MCQ booklet diya na maine, so those are very very important. Okay, you have to go through all those things. Around 20 questions we have discussed. Remaining questions we will discuss in the afternoon class. Okay, again I am having 3 to 4 lectures. At that time we will discuss the remaining MCQ questions. Okay.
Yes.
Yes. Okay. Whenever I ask any doubt or anything, you have to give response. Okay. It should be two-way communication. It should not be one-way communication. You are not supposed to listen. Okay. You have to give reply. Okay. And one more thing I wanted to ask. I have uploaded one first unit chapter notes also in the teaching diary. Have you observed?
Yes, sir.
Yes, sir.
Okay,
Yes,
that is
sir.
written notes I have uploaded. Just go through that. Okay, if at all any point is missed by me, then you can cover 99.99%. I have covered all the points. Okay, and there may be some problems. Okay, extra problem be high. Okay, just go through those problems. If you are getting any problem, you just text to me or send a picture of that problem so that I will clear your doubt. Okay. Next, I have uploaded the assignments also. Have you observed assignment 1 I have uploaded? Okay, there will be
Yes,
12
sir.
questions. There are 7 questions, 7 problems and 5 questions on theory questions. You have to write them and you have to make a PPT photo. Okay, you have to make a PDF of those whatever you are solving no. So उसका एक PDF बना के मेरे को submit करने का. I will give link. Okay, one link provide करते within the given time you have to all of you have to submit. Okay, so when you are solving each and every page के ऊपर आपका roll number लिखने का. Okay, if you have solved all the 12 questions within 20 pages में solve हो गया. Each page के ऊपर आपका roll number लिखने का. Okay, आपका roll number लिख के उसका PDF कैम स्कैनर में PDF करके मेरे को सबमिट करने का. Clear?
Okay. Yes, sir.
Yes, sir.
Is there any doubt to anybody regarding assignment, regarding MCQ questions, regarding unit 1 notes? Yes, sorry Ashwini, I am not able to hear you.
असाइनमेंट में क्या लिखना है सर?
असाइनमेंट में क्या लिखने का है? असाइनमेंट क्वेश्चंस दिया ना मैंने, वो क्वेश्चंस को आंसर लिखने का.
यस सर.
There are 5 theory questions and there are 7 problematic questions. Whatever I have taught in the classes, no, based on that one only there are assignment questions. एक सेपरेट नोटबुक में सॉल्व करने का, ईच पेज के ऊपर आपका रोल नंबर लिखने का, वो कैम स्कैनर में पीडीएफ करके मेरे को एक लिंक भेज दे, मैंने बाद में वो लिंक पे सबमिट करने का. Is it clear to everyone?
Yes, sir.
Yes, sir.
किसी को any doubt है क्या? See, you are having term work marks. There are 30 or 20 marks. That is based on your assignments and based on your attendance. Okay, you have to be submit within time. Okay, so
Sir,
okay, tell me.
name over here लिखने का नहीं.
If possible, write your name also. It is better because no one should copy your pages. That's all. Okay, आपका roll number and write your name also.
सर टीचिंग डायरी मधली पीपीटी ओपन होत नाही.
नहीं हो रहा क्या? Okay, I will check it. Maybe it may be private. PPT. No, I have made it to private.
नहीं सर, ओपन होता है सर वो पीपीटी, मगर जब हम डाउनलोड करते हैं ना,
हाँ
तो वो फॉर्मेट अनसपोर्टेड कहता है सर.
वो फॉर्मेट अनसपोर्टेड है.
हाँ.
सर उसके लिए अलग ऐप है.
हाँ देखो चेक करो कौन सा ऐप है उसका. ये
नहीं,
WPS में ओपन होता ना. WPS
पीपीटी रीडर.
नहीं, WPS या क्या ऐप है ना, उसमें PDF ओपन होते, उसमें वर्ड फाइल ओपन होते, उसमें PPT ओपन होते, सभी फाइल्स ओपन होते. WPS
नहीं सर, एक आध बार वो प्रॉब्लम करता है, नहीं तो ओपन होता
है. ऐसा क्या? ओके, इन केस आपको डाउट है तो मतलब ओपन नहीं हुआ तो यू कैन टेक्स्ट टू मी, व्हाट्सएप कर सकते हैं, मैंने व्हाट्सएप में भेज सकते हैं आपको PPT वगैरह. ठीक है.
यस सर.
किसी को ओपन नहीं हुआ तो you can text to me, WhatsApp कर सकते, so that I will send through WhatsApp or Telegram. Okay, so now around 47 students are present. Without making delay, we will start to the next chapter. Okay, so in your engineering mechanics there are 2 sections, section 1 and section 2. So in the section 1, resultant of coplanar forces we have seen. Okay, the coplanar forces are concurrent and non-concurrent we have seen. So next chapter is equilibrium of rigid bodies. Equilibrium of rigid bodies. See, from the first chapter, it is of 5 hours only. I have taken 20 hours in order to complete the first chapter. Okay, around 20 classes I have taken, 22 classes. Okay, the intention behind this 20 classes, you have to get understand. Okay, पहले chapter आपको understand हुआ तो you can understand all the chapters. So, is there any doubt to anybody in the first chapter? किसी को doubt है क्या?
नो सर.
Okay.
No.
नो सर.
Okay. Omkar, you can close your video, mute your video. Omkar, roll number 16, 17. Okay. So coming to the second unit. So all of you write your heading. So in the new page, write unit number 2. Unit number 2. Wait a minute. It started recording. Yes, it is started. Unit number 2, equilibrium of rigid bodies. Equilibrium of rigid bodies. Equilibrium of rigid bodies. So today it is work for you. You have to read all this syllabus. Okay. So in the first chapter, first page, you have to read all this. So like in the first unit starting होने के बाद हमने syllabus लिखा था ना, correct? All of you are remembering? Resultant of coplanar forces में syllabus लिखे थे ना, वैसे ही ये syllabus भी आप लिखने का. Anyhow, I have dictated in the first lecture only. Okay, all the 8 units 8 chapters का syllabus मैंने dictate किया था. Okay, second unit का syllabus आपने ये लिखने का. Okay. Okay, so what is your title? Equilibrium of rigid bodies. So what is about the title and central idea of the chapter? First means we have to study what is the title meaning. Title meaning क्या है? First you will study. Equilibrium means what? Equilibrium. Equilibrium is a condition of balance. Condition of balance. Okay, a body is said to be in equilibrium. A body is said to be in equilibrium if its condition is rest or state of uniform motion remains unchanged or unaltered. Okay, so see, this is a body. Okay, this is a body. I will write it here only. Consider this is a body. Okay, so if this body is not at all changing its position, not at all it is changing its position, means this is under equilibrium. It is under equilibrium. See, a body is said to be in equilibrium. It is said to be in equilibrium if its condition of rest or state of uniform motion remains unchanged or unaltered. So today the body is here, tomorrow is also here, day after tomorrow also here. It means the body is in rest condition only. Okay, now consider this is earth. Earth, is it in a rest or it is in motion?
Motion.
Motion. So today earth is rotating, tomorrow is also rotating, day after tomorrow also it is rotating. Is it in a continuous motion only?
Yes, sir.
Yes, sir.
Okay,
Yes.
it will not change its motion. Okay, it means the earth is also in equilibrium condition.
Equilibrium.
Okay, so if you consider this is a stone page. Okay, so this is a table. Okay, this is a table which is there today here. Tomorrow there is no force is acting on it. Okay, so tomorrow is also here, day after tomorrow also. Whenever you see the state of rest is same only, it is not changing its position, means the body is in equilibrium. So what is equilibrium means? It is a condition of balance. It is a condition of balance. A body is said to be in equilibrium if its condition of rest or state of uniform motion remains unchanged, means it is not changing its state of rest or its uniform motion. So is it earth, is it going to change its motion? Change hota kya? No, it
No,
will be
sir.
under motion only. Okay, when you consider a sun ka position change hota kya? It will be under same only. Okay,
No.
yes. Okay, who can change its state of rest? So who will come and change its position? Now the stone is here, so it is in
External
equilibrium.
force.
So it's a state of rest or the uniform motion is going to change by the external force. Who will change its state? It is external force. Then what is rigid body? What is rigid body? You have studied in the first chapter. Rigid body is a body which do not change its dimensions under the action of forces. Under the action of forces. So इसके ऊपर force डालने के बाद it should not change its dimensions. Okay, it should not change its dimension, or distance or the relative position of between the two particles is fixed. See, the distance between these two vertical component is d. If you apply the force, it should not change. It should not change. Then that is called as the body is rigid body. So what is the title of this chapter? Equilibrium of rigid bodies. We are studying equilibrium of rigid bodies. Okay. So first of all, what is equilibrium? We will see. Who has seen equilibrium? When the number of forces keeps the body at rest, then the body is said to be in equilibrium. When the number of forces keeps the body at rest, then the body is said to be in equilibrium. Or you can also define like this: when condition of the body is unaffected. Condition means it may be in the state of rest or it may be in the state of motion. Okay, the condition of the body is unaffected or unchanged or unaltered. Even it is acted upon by the number of forces, then the body is said to be in equilibrium. Okay, it means yes, sir. So whenever you consider this is a body, इसके ऊपर there are forces are applying, F1 force, F2 force, F3 force. Okay, so there are so many forces are acting, even though the body is not changing. It is not changing, no change. It is not changing its position with respect to any other forces. It means the body is in equilibrium. If the resultant of the given concurrent force system is 0, then the body is also equilibrium. So you can call like this. This is one statement. This is also a statement. This is also a statement. First one is when the number of force systems are acting on a body at rest. Okay, that is also a body is called as equilibrium. So when the condition of the body is unaffected, even though if it is acted upon the number of forces, then the body is said to be in equilibrium. Okay, this body is acted by many forces, even though it is not changing its position. It is unaffected by the external forces, then the body is said to be in equilibrium. Or else what we can say, with respect to all these forces, there is a resultant force. If that resultant force, okay, if this is a resultant force, if this resultant force is equal to 0, if this resultant force is equal to 0, then the body is said to be in equilibrium. When the resultant is equal to 0, when it is equal to 0, what is the resultant is equal to what? Sigma fx square plus
sigma fy square.
fy square. Okay, can you tell me when it is equal to 0? R is equal to 0 when sigma fx is equal to 0 and sigma fy is equal to 0. Okay, if these both are equal to 0, if both are equal to 0, then only r equal to 0, correct? So what is sigma fx equal to 0? What is sigma fx is equal to 0 means what? Sum of algebraic sum of all the forces along horizontal direction is equal to 0. Okay, then what is sigma fy is equal to 0? Yes,
Vertical direction sum.
yes, algebraic sum of all the vertical forces along the vertical direction is equal to 0. If there is no force in the horizontal direction, if there is no force in the vertical direction, then its the resultant is also equal to 0. When this resultant is equal to 0, then the body is said to be in equilibrium. Are you getting what is equilibrium?
Yes, sir.
Okay. Then, sir, what is equilibrium of force? What is equilibrium force? The force which keeps the body at rest is known as equilibrium force. The force which keeps the bodies in equilibrium is called as equilibrium of force. See, consider this is a one body. Okay, it is moving like this. Earth is moving in this anti-clockwise direction. Now I will apply another force in this direction, clockwise direction. This is F1 force. Okay, I will apply F2 force. If this F2 force is trying to making Earth as rest. Okay, if the Earth brings to rest, then this force is called as equilibrium force. Are you getting? The Earth is rotating initially. Another force will apply. I will apply. Okay, then the Earth will stop its rotation. Its rotation will stop. It means that external force को क्या बोल सकते हैं हम? That is equilibrium force. The force which keeps the body at rest is known as equilibrium force. सभी को clear है?
Yes, sir.
Yes, sir.
All of you read on this definition first. Equilibrium.
Sir, वो first page.
Will you read that one? Equilibrium. So same thing only I have to. Okay. Read this. About the title. All of you read this one. About the title and central idea of the chapter. First is equilibrium. Then a body. Then who can change it? Don't read this one, okay? Or if you want to write it, no problem. First is equilibrium. Next one is a body is said to be in equilibrium. Then third point is who can change its state. And fourth one is the rigid body. Have you written?
हो गया सर.
Yes, sir.
So you can take the screenshot also. Okay, if you want, you can take the screenshot and you can write it later also. Okay, have you taken?
Yes, sir.
Okay, take this screenshot so you can write it in your notebook. Next, okay, there are two types of conditions. One is analytical conditions and one more is graphical conditions. In the resultant of forces also, there are two types of method of finding the resultant forces. One is analytical method and one more is
Graphical method.
graphical method, correct, in the finding the resultant of force. Similarly, there are two conditions for the equilibrium. So conditions of equilibrium for the concurrent force system. So first one is analytical method. So what is analytical method? First one is sigma fx equal to 0, sigma fy is equal to 0, then r is equal to 0. Conditions क्या है equilibrium का conditions? Sigma fx is equal to 0, sigma fy is equal to 0. It means r is equal to 0. What is sigma fx equal to 0?
Horizontal component 0.
Don't say
Algebraic sum of horizontal. Algebraic sum of
algebraic
horizontal
sum of
components.
all the forces along the horizontal direction is equal to
Horizon-
0. And sigma fy is equal to 0 means
Algebraic sum of vertical component.
algebraic sum of all the forces in the vertical direction is equal to 0. Then r equal to 0 means
Fx and Fy.
0.
resultant force must be equal to 0. This is condition for the
0.
equilibrium. Then conditions for the non-concurrent force system. This is for concurrent force system. Okay, if it is a non-concurrent force system, then if the non-concurrent force system also sigma fx must be equal to 0, sigma fy must be equal to 0. It means resultant is equal to 0 हो गया. Then one more term, that is moment. Some algebraic sum of all the moments must be equal to 0 for non-concurrent force system. Okay, so take down this point. Analytical conditions of equilibrium. Analytical conditions of equilibrium. Among that, first one, conditions of equilibrium. Conditions of equilibrium for concurrent force system. For concurrent force system. Next point, sigma fx is equal to 0. Sigma fy is equal to 0. And r is equal to 0. Next point, the conditions of equilibrium. Conditions of equilibrium for non-concurrent force system. For non-concurrent force system. Sigma fx is equal to 0. Sigma fy is equal to 0. R is equal to 0. Summation of m about m is equal to 0. Okay, these two are for concurrent force system and non-concurrent force system. This is analytical condition. Then what will be the graphical conditions? Next point is graphical conditions of equilibrium. Graphical conditions of equilibrium. See, in case of graphical conditions, the concurrent force system, the vector diagram must be closure diagram. See how it will be. See, concurrent force system means what? Concurrent force means what? So consider this is one point. Okay, there is one force, there is another force, and I will take this is third force. This is F1 force, this is F2 force, and this is F3 force. Okay, so how I will write it is the vector diagram must be closed figure. So F1 force, I will write it F1 force. Okay, F1 parallel to F1. This is F2. F2 is like this. So this is F2. F2 okay. F3 is in this direction. So F3 is in this direction. F3 is in this direction. So is it opened or is it closed?
Open.
Open, sir.
Means this is not in equilibrium. It is not in equilibrium. If there is another force in this direction, this is F4. Okay, this F4 will start from this point. This is ending at this point. This is F4 point. If the starting point and ending point of this vector diagram is closed, then you can say that this body is in equilibrium. Are you getting? The starting
Yes,
and
sir.
ending point of the vector diagram is closed, then we can call it is equilibrium condition. This is graphical condition. Okay. If it is not closed, it means there is the existence of resultant. Okay. As per the law of which law? Of triangular, law of polygon. So this is polygon, no? 1, 2, 3. This is polygon. Okay. If it is not closed, it means there is the existence of resultant. Okay. This will be the resultant in the opposite direction. Correct. As per the law of polygon. Now it is closing means there is no gap. If there is no gap, it means resultant is 0. Okay. This is one point. Next, another point. Another point, for non-concurrent force system, the funicular polygon must be equal to 0. So for non-concurrent force system, see, first one we have seen for the concurrent force system, the vector diagram must be equal to 0. For the non-concurrent force system, so non-concurrent means there is one force here, another force is here, another force is here, okay, another force is here, another force is here. Like this. This entire is called as, this is funicular. Okay, for it is like a funicular. Okay, this entire, it should be closed one. It should be one. This is the called as funicular. Okay, funicular. The funicular polygon must be this closed figure. So now it is closing. If it is closed, then the non-concurrent force system, that is in equilibrium conditions. If it is not closing, means then that is not in equilibrium conditions. These two are the conditions for the graphical conditions. First one is concurrent force system, the vector diagram must be closed figure. For non-concurrent force system, the funicular polygon must be closed figure. Is it clear, everyone?
Yes,
Yes,
sir.
sir.
Okay, write it. All of you write these two conditions. Graphical conditions of equilibrium. Graphical conditions of equilibrium. Is it over?
Yes, sir.
Is it over or no? Graphical conditions. Everyone. Yes. Can you move to the next slide?
Yes, sir.
So next point is free body day, free body. So what is called? First, you know body. Okay, body is one. What is body?
Object.
Okay, only that much. What was the definition that I had given? Open your page, first page of your notebook. First page of your notebook, first or second
An
page.
objective which has a definite mass
Which
and which occupies the definite space.
Yes, it is object which has occupying
Definite.
definite mass
definite element. Okay.
definite space.
It is called a body, and you have studied rigid body, elastic body. Now it is free body. What is this free body? When the body is separated from its surrounding for considering the equilibrium, the body is under any force system is called as free body. So consider any body, इसके ऊपर weight apply हो रहे थे. Okay, it may be self weight, or it may be external weight or external forces. So if it is resolved or if it is removed all the forces, then the body is called as free body. It should not be subjected to any forces. Then it is called as free body. When the body is separated from its surrounding means it's a self weight and it's external forces. For considering the equilibrium consider करने के लिए the body is separated from its all surrounding forces under any force system is called as free body. Okay, so what is free body diagram? There is a diagram, free body diagram. A diagram in which all the active and reactive forces shown in the free body, which is separated from its surrounding, is called as free body diagram. See, all of you consider. So this is one figure. Okay, this is ground. Okay, this is ground. So in this ground, I will draw. There is a one. So this is a ball. Okay, think that this is touching the ground. Okay, so this is touching the ground. Okay, so there will be some weight. So this is solid metal rod, metal ball. Okay, metal ball. Okay, so it has some weight. Correct name? It has some weight, and when it is touching the ground, from the ground there will be some reaction. Are you getting?
Yes, sir.
It is a solid ball, solid metal ball. This metal ball is having some weight. That is W is acting downward direction. And when it is in contact with the ground surface, this is ground surface, ground level. Okay, there is a reaction from the ground. So this body,
Normal reaction.
this body I will draw like this. And it is not, I am removing all the forces. What are the removed forces? This weight I will remove. This reaction also I will remove. So this is not called as free body. Okay, so this is called as free body. So this is free body. Okay, the body is not subject to any forces. See, the free body is separated from its surrounding. For the considering the equilibrium consider करने के लिए, it is separated from all the forces or from all the its surroundings under any force system. So इसके ऊपर कितना भी force डाल दो. So I am removing all those forces. I am considering only I am isolating that particular body. Is called as free body. Then what is free body diagram? It is a diagram which all active and reactive forces are shown on the free body, which is separated from its surrounding, is called as free body. This is a body. So I have to apply all those forces, whatever forces I have removed. No, I have to apply all those forces from this or to this free body. What are all the forces? Can you tell me? First one is this is, it is weight is one force, and another force is there is a reaction from the ground. These are the two forces which are acting on this body. Now it is called free body diagram. Free body diagram. Are you getting the free body and free body diagram?
Yes, sir.
Free body means only I am extracting that body. I am removing all the forces. Only I am taking only body. Body is free from all the forces. Free body diagram means for that particular body, I am applying all the active and reactive forces. Active forces means it's a self weight and also external forces. Reactive means so it's a normal reaction from the contact surfaces. Here the contact surface is what? So from the ground is the contact surface. I will take one more diagram. Okay, I will take one more diagram. So this is one diagram. Okay, this is one surface. So over this surface there is a one consider this is one and this is one more. Draw the bigger diagram. Okay, now you can tell me. So I will apply one force here. I will apply. There is one more force here. Okay, I will take F1 force. What are the active forces? Active forces. So I will take same body first. I will isolate the body. So how I will isolate? This is the body. Okay, I will take. This is free body first of all. Okay, there is no any other forces. Are you getting? This is free body. Now I will show the active and reactive forces. What are the active and reactive forces? Now there is a force F1. So this is F1 force is acting like this, and there is one more force. What is that? It's a total weight. This is solid body. This solid body ka total weight hai, that is acting downward direction. Correct. Again, there are contact surfaces. Correct. This is one contact surface. There is a contact between the body and surface. Correct. There is a contact surface. There is contact surface. Okay, I will write it. I will draw here. There is a contact surface, and there is one more contact surface here, and I will draw like this. So what are the reactive forces and what are the active forces? Can you tell me what are the active forces and what are the
Sir,
reactive
weight
forces?
and F1 are active.
Weight
and
is active force
active.
and F1 is active force.
Active.
Okay, what are the reactive? That is reaction.
Other tools.
This is
Yes.
R1 is reactive force and R2 is reactive force. Okay, now this is called as what? This is free body diagram. A body which is represented all its active and reactive forces. All its active and reactive forces from its surrounding is called as free body diagram. Is it clear, everyone?
Yes, sir.
Okay. Draw this diagram. Write it. All of you write it. Free body. Free body. Right. All of you write it. Definition. Free body. When the body is separated from its surrounding, for considering the equilibrium, of bodies under any force system, is called as free body. Underline the term free body. Free body को underline करिए. Second one is free body diagram. A diagram in which all the active and reactive forces as shown on the free body, which is separated from its surrounding, is called free body diagram. So draw this is example. Draw the ground level. don't write these two. Okay, don't write. So in the initial level there will not be any force. Okay, just show it is solid metal. Okay, in the free body diagram you can show all these two. So initially body is here, iska just wait रहता. When you are showing in the free body diagram, so show it. Same solid body is shown like this, and there is a weight W and R is reaction. This is example 1 and this is example 2. So now if there is a solid body, for this there is external force F1. So this is contact surfaces. Okay, you can draw surfaces like this also. Like this. So now you are extracting this one, okay, isolating. This is a body, weight is acting downward. Weight is acting downward. So this is weight. This is the weight, downward acting downward. This is F1 force, this is R1, R2. So here you can write active forces. Active forces. Active force. What are the active forces? Weight
And F1.
Weight of body. Weight of body. F1 external force. External force. External force. And reactive. We can take reactive. Reactive forces. Reactive forces. What are the reactive forces? R1 and R2. R1 and R2 are the reactive forces. Is it over?
Yes, sir.
See, active force means applied forces and weight of the body. Am I right? Correct? No? Active force means applied force and weight of the body. Reactive forces means reactions offered by the ground, floor, string, or rope. Okay. Now whatever I have shown, there is ground surface, or there will be floor or any support system. So reactive forces means reactions offered by the ground, floor, string, or rope. Okay. So read these 2 points. Active forces means applied forces and weight of the body. Next point, reactive forces means reactions offered by the ground, floor, string, rope, etc. Clear?
Yes, sir.
Okay. Next is very important, Lemmy's theorem. Also write down this one. So very important. Okay. For the solving all the problems and also for the derivation. Okay. So what this, okay, all of you concentrate, don't write anything. So what it says, Lemmy's theorem. Okay. So as per the Lemmy's theorem, it's actually LEMI. Okay. LEMI. As per the statement, all of you are giving concentrating. You don't look at here and there, just look at the slides. Okay, what I am explaining, this is very, very important. As per this statement, it states that when three concurrent force systems keeps the body in equilibrium, then each force is proportional to the sine of angle between the other two forces. Angle between the other two forces. So now you know concurrent force means, what is concurrent forces means?
Same point.
All the
on the
forces
same
are
point.
passing through the same point. Okay,
Point.
it means in order to apply the
Same point.
Lemmy theorem, the force system should be concurrent force system. And one more is, the body is in equilibrium. The body should be in equilibrium. There should not be any disturbance. It should be equilibrium. Then each force is proportional to, how many forces should be there? There should be only three forces. Okay, there should be only three forces, and each force is proportional to the sine of angle between the other two forces. So if F1, F2, F3 are the three forces, concurrent forces, then F1 divided by sine alpha is equal to F2 divided by sine beta is equal to F3 divided by sine gamma. So how will be the diagram for this one? Okay, just take the definition. So we will derive how it will be. All of you take this diagram statement. Lemmy theorem. L-A-M-I-S. Lemmy's theorem. This is very, very important. So take, it states that when three concurrent forces keeps the body in equilibrium, comma, then each force is proportional to the sine of angle between the other two forces. Write this formula. F1 divided by sine alpha is equal to F2 divided by sine beta is equal to F3 divided by sine gamma. Have you taken?
Yes, sir.
Okay. So how it will be? I'll concentrate here. So there are three concurrent force system. So I will take three concurrent force system. This is okay. So this is one force, and this is another force, and there is one more force. This is another force. Okay. So these three forces are acting on a body, and these three forces are making an angle. So I will consider this is F1 force. Is it visible? White screen.
Yes,
Yes,
sir.
Yes, sir.
F1 force, F2 force. I will take this is F3 force. So this F1 force, this is a space diagram. I will write it. So how to denote by Bose notation? What is Bose notation? It should be represented by which letter?
Encircle.
Capital letters.
Circle.
Okay. So which circled?
Circle.
I will take this is A, this is B. F1 force is AB. I will take another force F2. F2 force is BC. And what about the F3 force? It is CA. Okay. Then this F1 is making an angle alpha. Angle between the other two forces is alpha. And F2 opposite angle between the other forces, it is beta. And F3, the angle between the other two forces, it is gamma. Are you getting, all of you? F1 is this one. The angle between the other two forces is alpha, and F2 is this force, and the angle between the other two forces F2 and F3 के बीच में कितना है? That is beta. And F3 force is this one, and angle between the other two forces is how much? It is gamma. All of you are getting?
Yes, sir.
Okay.
Yes, sir.
So now what I will write this AB. So this is which diagram it is? Is it a vector diagram or space diagram?
Space diagram.
It is
Space.
space
Space.
diagram. Space diagram. Space diagram. Okay. So now what is this AB? AB means what? That is equal to, I will write it in vector diagram. I will transfer this space diagram to vector diagram. I will transfer this to small AB. That is equal to how much it is? F1 force. Then BC. BC is in space diagram. In vector diagram, it will be small BC. And that is F2. In CA, CA is small CA, and that is equal to F3 force. Okay, so I will transfer this space diagram into vector diagram. How to transfer this space diagram into vector diagram? You have studied how to transfer. We have to draw the parallel lines. Correct? No, we have to draw the parallel lines. See, F1 force is in this direction. I will draw like this. Okay, I will start from this point. I will draw the like this. Is it okay? I am drawing parallel to the F1 force. Is it okay?
Yes.
Everyone? Okay.
Yes, sir.
So it is A, this is B. Okay. Next, F2 force. F2 force starting from the, I will, where F1 is completing, from that point, F2 will start and it should be parallel to F2. So this will be the F2 force. It is starting here. This will be the F2 force. Okay. Then F3 force should be where F2 force is completing. From that, F3 will start and it is in downward direction. So it is in downward direction. It is in downward direction. Okay, so what I will do, just I will extend this force. I will just extend this one. Okay, all of you are getting what I have done?
Yes, sir.
F2,
Yes,
F3,
sir.
okay. Okay, now what I will write? So what is this one? What is this force? Can you tell me? What is this one? F1.
F1.
What is this one?
Yep.
F2. What is this one?
F3.
See, angle between F1 and F2 is kitna hai? Angle between F1 and F2.
Gamma.
Gamma. See, F1 is here, F1 is here, F2 is here. That is exterior angle. F1 के बाद F2 आते. So this angle कितना है? This is gamma.
खाली कर लो तरा से.
Are you getting?
तो बस
Yes, someone is talking.
Yes, sir.
Please mute yourself. Roll number 25, Prajakta. Please mute yourself. Okay. See what I have done. So the angle between F1 and F2, that is beta. Sorry, gamma. So this angle is exterior angle is this is gamma. Okay. Now I will erase this one. Wait a minute. Just. Okay. Okay. See, I will remove this one. Okay. Later, confusion. Okay. This is F1 force, and F1 force is making an angle gamma. So gamma between F1 and F2. Then F2 and F3. This F2 and this is F3. What is the angle between the F2 and F3? Alpha. This is F1. F1 is going like this, and this is F3. So this angle is how much it is? It is alpha. Okay. Then F3 and F1. This is F3 and this is F1. The exterior angle, how much it is? It is beta. Okay, beta. See, consider all of you consider this F1 force. F1 force is exactly straight line. Correct. The angle of a straight line is how much? एक straight line का interior angle कितना रहता? 180. So if this is equal to gamma है तो what is the angle made by the inside angle? That is 180 minus gamma. Is it correct?
Yes, sir.
Then can you tell me what is this angle? This angle is how much? If exterior angle is equal to alpha, interior is 180 minus alpha. Then what about this angle?
180 minus
180 minus
180 minus beta.
beta. Okay. Okay. Now, as per the statement of Lemmy's theorem, what it says, according to the statement of okay, I will write all the things. First, all of you draw this one. All of you draw this one. Diagram draw करो. बाद में लिखेंगे. Almost it's time up. All of you draw this diagram. This is vector diagram. Vector diagram. AB is equal to small ab is equal to f1. BC is equal to f2. CA is equal to small ca is equal to f3. Calculate this one. Okay. Are you ready?
Yes, sir.
Roll number 19. $27, 31, 43, 53, 59, 19, 27, 31, 43, 53, 59.
Present.
What is the number?
59.
Yes, 59 is present. Okay. 19, 27, 31, 43, 53. These are the objectives.
Sir, 38 present.
30th present. Okay. 31.
38, sir, 38.
38. I have not said any 38. No. I have said 31, 43, 53 absent numbers. So what numbers I am calling? Those are the absent numbers.
64 last, sir.
Yes, 64 is present. We have written. Okay. As per the applying sign rule, what does sign rule says? Each force is directly proportional to the sine of the angle between the opposite two forces. So this is F1 force. Okay. This F1 force is directly proportional to what is the angle between the other two forces? How much it is? How much? It is sine of 180 minus alpha. And F2 force. F2 force is directly proportional to, this is F2 force. Directly proportional to sine of, yes, what is the opposite angle? Opposite angle is 180 minus beta. And again, F3 force. F3 force is directly proportional to sine of
180 minus gamma.
180 minus gamma. So all these are proportional to each other. So how I will write? F1 divided by sine of 180 minus alpha is equal to F2 divided by sine of 180 minus beta. This is equal to F3 divided by sine of 180 minus gamma. What is sine of 180 minus alpha?
Sin alpha.
Sin alpha, correct? So this F1 is equal F1 divided by, so F1 divided by so this F1 divided by sin of 180 minus alpha. Can I write it as sin alpha? This F2
Yes,
divided
sir.
by F2 divided by sin of 180 minus beta, that is equal to sin
Sin.
beta. So this F3 divided by sin of 180 minus alpha. So that is F3 divided by sin of gamma. Okay, so this is entire your as per the Lemmy theorem. This is the formula how to derive, that is sine rule, or it is Lemmy theorem. What does Lemmy theorem says? It is each force is directly proportional to the sine of the angle made by the other two forces. F1 is the force and it is making an angle alpha between the other two forces, and F2 is the force and which is making an beta by the other two forces, and F3 is the force and which is making an angle gamma between the other two forces, that is sine. F1 divided by sin alpha is equal to F2 divided by sin beta is equal to F3 divided by sin gamma. Is it clear, everyone?
Yes, sir.
Okay, the dictation will take in the next class. Okay, okay, we'll stop now here. So we'll continue in the next class. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Wait a minute. Okay, fine. We'll continue in the next class. Okay. Thank you all. Yes, sir.